This conference will now be recorded.
Okay, so now today we are moving to a very good topic, that is the BiCMOS technology. So already you are aware about the CMOS technology. The CMOS is a combination of PMOS and NMOS, but here this technology is something different. But here, some think this technology is something advanced as compared to the CMOS technology, because here the architecture or some device are something different in the BiCMOS technology. In the BiCMOS technology, there is device is something new. That means this technology is something better as compared to the normal CMOS technology. So that is our agenda for today. What is the BiCMOS technology, and using this technology using this technology, how to design some circuits like a CMOS inverter, like an inverter. Okay, we also discussed this using the BiCMOS technology, how to design the inverter logic. So first thing you understand the CMOS technology. CMOS, the power consumption is less in the CMOS, and here the driving capability of CMOS is better, because means the switching speed. If you talk about the switching speed, means here in the CMOS, actually in the CMOS is like fast switching speed, like 0 and 1 or 1 or 0. The speed of this conversion of the logic bits in the output mode is something very high. Okay. But here, some new parameters are involved. That means the computation is more fast. Okay, we discuss more sometimes. So now we do not waste more time here, because this topic is now something new, and this is industry trends. Why industry are using the BiCMOS technology for the circuit design point of view. Okay, so here actually you know the VLSI. What is VLSI? In a small scale, you fabricate a more number of transistors. If the complexity of circuit is day by day more, that means this is a VLSI technology, and this is a VLSI trend. What are the research are going on this field, that is only based on the optimization. So optimization is totally depends on the device. If your device is good, your device performance is good, of course your circuit performance is very, very good. Here why this something new things are there, BiCMOS. Okay, so just to aware about this transistor, maybe NPN or PNP. So BiCMOS is merged together. If you merge these two technology, then your performance driving capability of the circuit is very, very good. Okay, we discuss something after sometimes why this performance is better, because previously I discussed in the bipolar type of transistors there is some leakage current or something high power consumption, but here something more features or more advancement is possible here if you combine these two devices. If you singly use the bipolar to formation of some logic circuits like OR and NOR, but this is not good. This approach is not good. But if you combine these two technology, this is one, this is second. If you combine these two technology, then your performance of circuit is good. that type of circuit is known as the BiCMOS technology. It is a combination of transistors, BJT transistors, and the CMOS device like NMOS or PMOS. Then your performance is good. But here the combination is very important. If you are not combined, then your bipolar performance is not good. It is obviously it is correct. All the time it is correct. Bipolar transistor has more disadvantage as compared to CMOS device. But here, if you combine these two devices in a very effective way, we discussed what is a very effective way, how to combine these two devices, and then your performance is better. So that is our agenda for today. So just to understand, the BiCMOS is a combination of CMOS and, another is a BiPo combined in a single circuit. In a single circuit, you combine both type of device, then your performance of circuit is very good. I will discuss also the performance parameters, what are the equations are available in this technology, and how my performance is better. Because we are the engineer, we have go for the analysis. Without analysis, I do not conclude by my, I do not say my performance is better. So that means the analysis point is very, very important. Then you have to conclude that this is a better technology as compared to CMOS technology. Okay, so I think it is very, very clear. So something we noted on this. What is the so already I discussed the bipolar is a combination of bipolar CMOS is actually this transistor NPN or PNP and a CMOS. Both are the combination. CMOS BiCMOS is a combination of these two. So right, CMOS transistors. Maybe your type NPN or PNP. You require two type of device to complete the circuit. So it is very clear here. So now actually what you are doing, uh, you are mix some parameters, both these parameters. One is you mix circuit, then your output node performance is very, very better. So that is very interesting case here. So here something is both the one is a bipolar, another is a CMOS. Then your cost point of view, if you suffer is very costly, the material to fabricate the device, the material is a wafer. If the wafer, if you are using more number of wafers, then your cost is high. Then we do not compromise the cost. Every time the cost of the circuit is very, very less. That's why here in the BiCMOS technology, you are using a single wafer, and in the single wafer, you are using some fabrication technology like diffusion, epitaxy. So much technology is there. Using this technology, you have to combine the both type of device. One is PMOS, one is CMOS, and another is the bipolar. But wafer is single. Your wafer is not so much number of wafers or replica of wafers. These here, your cost point of view, this circuit less. The cost is not so much high. So that is a very, very good point here. So anything bias problem? Okay, so I already discussed the cost point of view. This technology is not very high. It is good. So because here we are using a single wafer. In the single wafer, you have to fabricate a bipolar and CMOS. Then of course, the cost point of view is not so much high because every time we are checking the cost because the user has demanded the VLSI chip in a low cost. If your cost is low, the performance is high, then your chip or IC to be sell in the market. That means we are the like a greedy industry. Every time the industry, semiconductor industry, they are saving our money. So that means the technology is day by day is going to in the advance. Okay. So that's why so many technologies come in the market. So that is our your subject. Your subject is going from the is lower level to the advanced technology. That is the uh, that is your VLSI domain or VLSI subject here. So here, okay. So discuss here in binding these two types of device, bipolar and CMOS. So that means you have to learn about the features of this two type device, and then you merge. Then of course something better outputs. You have to see in your architecture point. So here the switching speed is high. Okay, this and this is the color. Your IV current so now here in the output, I already tell you the driving capability concept is equal to this already you know this formula 1 plus beta times beta is the parameter. Feed these parameters, this equation. Then you this term is 101, and then you this parameter is very high because the beta of the transistor is very high type of transistor. Beta if you purchase the so if the beta okay, something okay. So everything is okay. My voice is something good. Okay, so actually, what is the main thing? What is the thing? Here the beta value is 100. The beta value is 100. If you calculate this equation 1 plus beta, so this value is 1 plus 100, that is 101. That means if the current base current is very less, but here this multiplication factor is very high. If this multiplication factor is high, then your emitter current is very high. That means your output node voltage is swing very quickly because if the current is high in the node E, this is a emitter node. Of course, here you take in some output. Okay. If this IE current is going very fast or very high value, because in according to this equation, your IE value is 1 plus beta times IB. But if your IB current, your base current is very less, but the another parameter is multiplied here. This is 1 plus beta times. So that means this IE current very high. If this IE current is very high, your output is going in a very fast way, 100 like this. The speed of the switching is going to very. So that is important features in a bipolar junction transistor. This is not in case of CMOS. In the CMOS, there is same current, whatever the intercurrent, but is output current is same. But here, our emitter current is, is very very high because this parameter is totally effect 1 plus beta effect on this IE. Okay, so now here so I think my system is actually high. Transistors in bipolar transistors actually the the process is your IE current is something if you IB. So if the value is less, the beta 1 plus beta term has increased this value to a very high. Another thing you have to carefully measure here, this in case of CMOS, okay, so here in case of power dissipation. So what is the meaning here? Okay, fine, it is good. So actually, in every time you see the CMOS device, if you see the CMOS device, suppose that this is my CMOS. Okay, suppose that this is my CMOS, this is the PMOS, and this is the NMOS, and both gate is connected here, and this is the VDD supply, and this is the ground, and now you take the output. But you carefully observe this is the PMOS. So here, if you see carefully, there is no static power in your circuit. What is the static power? Actually, there is one time your transistor is on. This is on or this is on, but both is not on at the same time. If it is both on, then current is flow here. Current is flow from here, lower, higher to lower. Then of course, the static power has played an important role. What is static power V into I? If your current is stabilized from VDD to ground, then the static power is very high. But here, this is the situation. This path is not connected in any way because this circuit is stuck here in all the times. If this is on and this is off, if this condition is always in this CMOS circuits, or this is off or this is on. So this is a situation you observe in case of CMOS inverter circuits. Your path is not connected in any way from VDD to ground because if this circuit is on, this is off. This is off. This is on. In this case, your current is not flow from this path. If this current is not flow, of course, your static power. If you talk about the static power, this is very zero. This is something very less. Power dissipation of CMOS circuit is very less. Because here the path is not available. The path is not that are not on at the stage. Only one transistor is on. So that is the feature in case of CMOS device. But now you are combining. Okay, now we go for the so here just I go for the uh, for the fabrication point of view, just to understand in the fabrication point of view, the CMOS and the P source and drain and the N source and drain. Here, text. Okay, in this slide, this is the complete actually structure of your. Just observe that in the left side we are fabricating. See in CMOS, and in the right side the fabrication of transistors in this diagram. Uh, Left this is a CMOS, and in case of right side this is a PMOS. So this is a bipolar. Both are fabricated on the single wafers. Okay, so just I discuss the circuit point of view because this is a very important. Okay, so this is a general structure of the CMOS, and this is a general architecture of BiCMOS. So the BiCMOS actually you are using two extra transistors. Okay, okay. So the drain is connected, and here this drain is connected here. This is a source. Now we go for the analysis point of view. Okay, so then this bipolar actually this is one part. This is the CMOS. On this side, you carefully observe. This is CMOS, and here this transistors. Your transistor is in this side, and this side is actually the CMOS or something. This is a bipolar transistor. Okay, so it is good here in this left side CMOS, in the right side this is a BiCMOS. So now here just analyze this circuit. If you apply some appropriate value, then what is the actual? Okay, if in some case logics. Okay, suppose that in this node we connect a logic 0. See the logic 0 in the if the input supply is 0, that means if this PMOS is available, current is available, your T1 transistor conducting mode. It is it is on the conduction mode. Conduction means it is capable to generate the emitter. So the condition about the condition, your condition case your, and the connection is stabilized from VDD to VDD to here. VDD is your DC supply, and here if this connection is available, your base current is available of P1 transistors in the upside. So if the base is, current is available or sufficient, P1 is on the conducting line. So if it is conducting, then you get your output. The switching is IE is, so this value is very high. Actually, this current. So if the capacitor is to understand very well, if the emitter very high, because here this parameter is 1 plus beta. That means if this base current is very less, you're high. If the emitter current is very high, your capacity fully charged in a very quick time. That means the switching necessity is very high. If you use the bipolar transistors in your circuit design, then your switching or capacitor in the output node is charged very quickly. So that behavior you have to analyze in the circuits. But in normal CMOS, it is not possible. It is required some time to charge the capacitor. But here, the time of charging of the capacitor is very, very less. Because here, the output node current, your IE output node emitter current is very high. Because here, the beta of the transistor is very high. The gain of the transistor or beta of the transistor is more than 100. That is the device property. That is uh, that beta in any all the cases the beta is something 50 or 100. This value is very high. Of course, my emitter current is very high. But if a higher value is multiplied by lower value, then you get the result higher value. That is the important features of the bipolar transistors. Your capacitor, your load capacitor is very quickly charged based on the emitter current. So this is the one case. This is the one case. So now I am interested to check the performance of you check the performance in case of logic 1. If your input is logic 1, you also check the output node voltage. We are also interested for this second case. So here in this second case, suppose that your input voltage is 1. This is a case 2. So here if the input voltage is 1, this is the NMOS. This is on. Okay, this is on. The connection connected here. This connection is connected here. So output voltage is already okay. So now here on here this T2 transistor. Okay, this is a T2 transistor. Now here the base current of this transistor is available because my PNMOS is on. Transistor. Why? Because here the sufficient current is available in the base terminal. So if a sufficient current is available, then your lower side T2 transistor is on. So here if it is on, your capacity is the ground. So now here if it is connected here, all the voltage, all the capacitor voltage is in the discharge phase. All the capacitor voltage is going in the discharge manner. It is going on the discharge because here higher voltage is connected to the lower, because so that means the higher voltage after sometimes the capacitor higher voltage is sometimes after fully discharged. So if it is fully discharged, your output voltage again go to the 0 volt, but here input voltage is 1. So that is the uh, inverter behavior. You know very well inverter is if the input is 0, output is 1, input is 1, output is 0. So here you have to analyze the same behavior in case of bipolar CMOS technology. Because here in the output node, you connected to extra transistor. Because the beta value, that if you observe the IE value, 1 plus beta times, in case of bipolar, 1 plus beta times IB. I did not discuss this formula derivation. You know IE is equal to IB plus IC. So IC, you know very well, IC is equal to beta times IB. IC is equal to beta times IB. Common beta IB. So that's why I written this equation 1 plus beta times IB. Okay, so that is clear. It is very clear in this picture. In case of so here in case of if you are using some bipolar device or transistors in the output node, your capacitor is very quick time to discharge. It is charge the capacitor is fully charged capability. Bipolar transistor, bipolar technology is very superior as compared to CMOS CMOS technology. But if you talk about the complexity, if you talk about the CMOS inverter complex, CMOS design and BiCMOS design. So in the inverter, there is only two transistors in case of CMOS, but here in case of a BiCMOS inverter, the complexity is high. Okay, that is one case that is understood. Here, this is a disadvantage of this bipolar technology. The complexity of circuit is high because here the number of transistors is four. Two transistors for two transistor is for CMOS and two transistor is for bipolar like NPN or PNP. The complexity is high, but we are compromised because here the my switching speed or the output node switching speed is very good. The driving capability is very good, but that's why this technology is adopted to all the industry, all the semiconductor industry. So that is the way. So we talk about the DC characteristics. Okay, so here the performance is good. I already tell you in the starting of this BiCMOS topic. Why this performance is good? I already analyzed all these equations. Your out immediate current in the output mode is very high because the beta value is high. It is very good concept here. The gain is very high. The gain is also very high in this BiCMOS technology because the beta is very high for all this type of transistors. and then emitter current is also high because the emitter current is directly proportional to 1 plus beta. So if the base current is less, your IE current is very, very good. It's not only compromising factor. That means the circuit gain is very good. We are talking about the gain of all the circuits. What is my gain? So if you talk about the gain, so you know this equation IE is equal to 1 plus beta times IB. So here if you see the is equal to IB plus IB, that is 1 plus beta. Beta is high, then your gain is also very good. This parameter is good. So this is the gain parameter is good in case when I the device. But now we are talking about the characteristics point of view. Actually, this is a DC characteristics. I already discussed in the previous lecture. In the CMOS, actually, this curve in the middle, I will tell you, this curve in case of characteristics, what is the DC characteristics? I already tell you, this is the characteristics we are plotting like output versus input voltage. Output versus input voltage. This is the characteristics of DC characteristics. Now here, if you vary some voltage, like input voltage, then you have to check your output voltage. This is very much you are under if input understand very well. So that you are plotting the DC characteristics. So that is the DC characteristics. So now here of curve is there. One is the curve for CMOS, another curve. So one thing you just remember, actually the W by L ratio not drop of DC characteristics is not to talk about the statistics. This curve is not very smooth. Here in this reason, this curve is not very smooth. The W by L is not accurately you have to set in the CMOS. But here this curve is very, very smooth by CMOS. Because this curve is going here in this very, very smooth. But in case of CMOS, the curve is like this. The curve is like this. Good. But here this curve is very, very smooth in case of BiCMOS So here this is a good performance. The DC characteristics is good in case of BiCMOS. Here W by L is uh, is not an create a problem. Here already your characteristics of the DMOS is very good as compared to the CMOS. And one more thing you have to under we are talking about the speed and we are talking about the area and we are talking about the delay. So actually the VLSI industry is a very greedy industry. They are talking about the low cost and high speed and low power. So here this technology, if you compare this is a CMOS and this is a BiCMOS, this is a curve we are plotting like load, uh, output load voltage, this is a load capacitor, and this side is a delay. So here delay is less in case of BiCMOS. But if you increase the the load capacitor, your CMOS technology has more delay. I mean, this is a good factor in case of CMOS. This is a good factor in case of CMOS. As we talked about this, talk about the delay. Delay is very less. Of course, the speed of the circuit, the speed is very high in case of BiCMOS device. So that's why this is. And one more thing, if you talk about the okay, if you talk about the one more thing, actually we are considering. So if this is load capacitor, if you connected up, you are capacitor. This is the load capacitor. Load cap and discharge is the output voltage based on the load capacitor voltage. If suppose that my in some case are now going to the lower value, then you say my output voltage is. So here, one thing, the area factor is something high as compared to the CMOS. Is high CMOS because you are using some extra time, you are using two extra bipolar devices. In case of inverter, that means the complexity of this circuit is high as compared to CMOS, but delay, if you design some high circuits, then your CMOS technology is fulfill your criteria. So that is the one way. If you talk about only speed, you are not a talk about area. You are talk about only speed, then you go for the BiCMOS technology. Because here the speed factor is good. Why I tell you because the beta, because the IE current is very high. Because IE current is charging the load capacity. IE is very high, 1 plus beta times IE. The beta is very high for all the bipolar transistors. Then your capacitor is fully charged, and your speed factor is very, very good. Area is something compromised. You have to compromise the area. So that's all for this session. So what is the application of this bipolar? So many memory design. You know the memory is a two type, SRAM or DRAM, static RAM, dynamic RAM. Okay, and all the microprocessor and microcontroller type. So, so, so many processors are there in your systems or mobile phone and all the laptops or computers. The processor is there. So in this type of uh, VLSI circuits, there is a BiCMOS is the application and semi-custom IC. So semi-custom means whatever you design, it is not fully uh, new. It is available. The library file is available in your EDA tool. Whatever the softwares that EDA tool has provided some standard cells like NMOS or PMOS or NPN transistors or PNP transistors. You are calling this library only, and then you go for some design or some architecture. That is a semi-custom. Semiconductor means you are utilizing our standards library, what are available in your software or some EDA tools or CAD tools. That is a semi-custom. So all the semiconductor, all the semi-custom IC, you are designing some register or flip-flops. They are the part of these circuits are based on the BiCMOS. Okay, some more application adapters. So many adders are there, so many variety of adder, ripple carry adder, and carry save adder. And one more thing, ADC unlock to operate. So many unlock to digital, and similarly digital to unlock apps. Okay, so these are the applications of bipolar transistors. So this is a small thing. This is a large scale
Sir, time over, sir.
so that's all for all things. So anything you have anything you have today lecture. So today you understand the BiCMOS technology, what is the architecture of the BiCMOS technology, and what is the analysis of the bipolar BiCMOS of the value of a already you learned static RAM or dynamic RAM or something PC or lock to type locks and semi-custom. So these are the very broad applications. These are the very broad BiCMOS technology, and this is a combination of CMOS and you have combined in single circuit.